Now it's time to look at composition of functions. The composition of a function is just another operation. So you've got addition, subtraction, multiplication, division, and now we have composition. Function composition is applying one function to the results of another. Really, you are replacing a function with a function. You've got to be careful, though. When you see that open circle, that does not mean multiplication. Likewise, the parentheses here does not mean multiplication. It's placing a function inside another function. So be really careful with the notation. But whenever you see this symbol here, f of g of x, it means the same thing as f of g of x here. I like to use the one on the right the most. So you'll see as we go through the examples, I actually change it to be the function notation on the right. It helps me to identify what function I need to replace inside of the other function. All right, let's take a look at example 1. So we have f of x is 3x plus 1, and g of x is x plus 2. So they're simply just two separate functions, and we're going to replace one inside of the other. All right, so I'm going to start with the f and then the open circle g of x. That means f of g of x. All right, so I'm going to keep all my f function in blue. So I'm going to say f of, and then g of x is going to be green. So when you take a look at how I changed it from one notation to the other, now I know that I have to take my g of x function, the x plus 2, and put it inside of the f. Okay, so you work with that innermost function first. Okay, so it's going to look like this. So this is equal to f at, and instead of g of x, I'm replacing it with x plus 2. Now, all the function notation is, it's like a machine. Whatever you put inside of those parentheses, that is what goes inside of, or replaces, I should say, the x in the f function. So I'm going to replace the x. So in the f function, it's 3 times x. So I'm just going to leave that parentheses open for now. And I'm going to put my x plus 2. So I'm replacing x with x plus 2, and now I can just work it out algebraically. I've got to distribute the 3, so I have 3x, 3 times 2 is 6, plus 1. So my end result is, I'm just going to put a little arrow here, 3x plus 7. All right, now what is f of g at 2? So all that is saying there is replace the x with a 2. So I have 3 times 2 plus 7. So that's 6 plus 7, or 13. All right, let's try another one. I know this can get confusing. Here I've got g of f of x. Okay, so whatever comes last there, that's what goes inside the parentheses. G of f of x. So this is equivalent to g of 3x plus 1, because that's what f of x is. So I'm replacing x in my g function with 3x plus 1. So it looks like this. G of x is x plus 2. Okay, so that's the template of my function g. I'm going to replace x with 3x plus 1. So 3x plus 1 plus 2 is 3x plus 3. So what it's saying now is, okay, if you have g of f of x, what is x at 2? So that's going to be 3 times 2 plus 3, which is 6 plus 3, or 9. Okay, very good. Let's try another one. All right, we've already done this one at the top. There we go. Okay, so let's look at example 2. So here we have f of g of x. It's already in the form I like it to be in. Again, I'm going to do my f function in blue, my g function in green. So I have f of, and I'm going to replace g of x with x plus 1, because that's the definition of g of x. Now I'm going to go back to my f function, figure out where x is. So it's 2 times x minus 4. I'm replacing that x with x plus 1. Now I'm going to distribute my 2. So I have 2x plus 2 minus 4, and then simplify. So it's 2x minus 2. If I replace negative 1 in for x, it becomes negative 2 minus 2, which is negative 4. So my f of g at negative 1 is negative 4. This is simply a coordinate point. So we're saying in the composition between the two functions, when we have x at negative 1, then the y value is negative 4. All right, let's look at g of f of x. Okay, so my g function's in green, so I want g, and then f of x is 2x minus 4. All right, so I look back at my g function, and it's x plus 1. So I'm replacing x with 2x minus 4. So 2x minus 4 plus 1 is 2x minus 3. So we have 2 times x minus 3, and if I replace it with a negative 1, it becomes negative 2 minus 3, which is negative 5. And there you have it, composition. So we'll do a quick warm-up, and you will have an assignment to work on.